Good day everyone. My name is Emmanuel Peña, ME1B, and I'm going to tackle about exotic metal heat exchanger. So, what is exotic metal heat exchangers? Heat exchangers made of exotic materials are typically used to prevent corrosion and extend the life of processes. It is employed in certain processes for both gas, condensation, and liquid application. The ability of heat exchangers to function in high temperatures and pressure settings is their main benefit. Aside from the discovery flashing the screen, I would like to share some information about exotic metal heat exchangers. Two systems must be in equilibrium with one another for them to be in thermal equilibrium with the third system. As a result, all three systems must be at the same temperature. This law specifies the idea of temperature and establishes it as a measurable property of thermodynamic systems. In addition to expressing thermal equilibrium as a transitive feature and coming before the other three laws of thermodynamics in sequence but not in development. The first basic principle underlying heat exchangers is the zeroth law of thermodynamics. As for the first law, it is referred to as the law of conservation of energy. Essentially states that energy cannot be created or destroyed, only transferred to another thermodynamic system or converted to another form. The second law of thermodynamics. It is also used to describe how two isolated systems have a tendency to gravitate toward thermodynamic equilibrium when they are permitted to interact and are not subject to any outside forces. According to the second law, entropy can never decrease and can only increase. Hence, each system must always advance toward its maximum possible value as entropy rises. Entropy can neither rise since it is at its maximum, nor decrease because doing so would break the second law in the system once it reaches the point of equilibrium. As a result, the only system changes that can occur are those in which entropy does not change. For example, the ratio of the heat added or subtracted to the system to the absolute temperature remains constant. Figure 1 below illustrates the various flow configurations available, including a cross or counter flow configuration, which is an example of a hybrid flow configuration. Heat exchanger, components and materials. There are several types of components which can be employed in heat exchangers, as well as a wide range of materials used to construct them. The components and materials used depend on the type of heat exchanger and its intended application. Some of the most common components used to construct heat exchangers includes shells, tubes, coils, plates, fins, and adiabatic wheels. Further detail on how these components function within a heat exchanger will be provided in the next section. While metals are highly suitable and commonly used for constructing heat exchangers due to their high thermal conductivity, as in the case of copper, titanium, and the stainless steel heat exchangers. Other materials such as graphite, ceramics, composites, or plastics may offer greater advantages depending on the requirements of the heat transfer application. The heat exchanging devices listed beneath the construction classifications are only a small sample of those available. Since there is no phase shift throughout the heat transfer process in single-phase heat exchangers, the warmer and cooler fluids continue to exist in the same state of matter as when they first entered the heat exchanger. For instance, in water-to-water heat transfer applications, neither the warmer nor the colder water turns into a gas or solid as the heat is transferred from one to another. However, in two-phase heat exchangers, fluid go through a phase shift when transferring heat. The phase change may occur in one, both, or none of the fluids, causing a transition from liquid to gas or from gas to liquid. Devices using two-phase heat transfer typically involve more intricate design considerations than those using a single-phase heat transfer. Boilers, condensers, and evaporators are a few examples of the different kinds of two-phase heat exchangers that are available. Condensers are heat exchanging devices that take heated gas or vapor and cool it to the point of condensation, changing the gas or vapor into a liquid. On the other hand, in evaporators and boilers, the heat transfer process changes the fluid from liquid form to gas or vapor form.
Liftoff will start in T-minus 10 seconds. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. We have ignition.